Okay, so we're going to look at the binomial expansion. So as you can see from the notes, I've FOILed things out like x plus 2 squared to equal x squared plus 4x plus 4. And x plus 2 cubed, and we've noticed what that is in the notes. And we're going to start looking at the pattern of these coefficients. Now, FOILing this one out does not show the pattern of Pascal, so I just wanted to introduce that. Sometimes we just don't do that. But now we're going to go and see an example, a plus b to the n. And I'm going to put a red box around that one. That is a general form that we're going to be working with. And when using that formula, we know that we have n plus 1 terms. And we're going to be using this formula, t, k. I'm going to write this off to the left. t, k, plus 1 is equal to nck, proper notation, nck, a to the n minus k, b to the k. And let's say that I'm looking for T5. Well, I know T5 is tk plus 1, the left-hand side of the formula. And then, therefore, 5 is equal to k plus 1. And if I subtract 1 from both sides, k is equal to 4. So I know that k is always 1 less than the term number. Seen in your notes, k is always 1 less than the term number. So if I have an example like x minus 5 cubed, it means that a is simply x. B, from the formula above in red, b is negative 5 because the formula says plus. And my n is simply 3. And I know that I have n plus 1 terms, so I know I have 4 terms. So those are going to be the features. Now down below, I've taken a whole bunch of a plus b's to a whole bunch of different exponents, and I've FOILed them all out, first, outsides, insides, last, and expanded them all to see. And notice we have this pattern of coefficients. 1, 1, 1, 1, 2, 1. 1, 3, 3, 1. And we know that that's Pascal's triangle, as we saw on the page before. So now using this general formula, how can we find terms in the future? So let's go back to a general form like a plus b, and let's say a plus b to the exponent 6, as in the bottom of the notes. Notice in the notes I've skipped over a big, huge, long formula. Feel free to use that formula or try and understand it from your textbook, but I'd prefer just to learn these things one at a time. So a plus b to the 6, and let's say we're looking for the 5th term. Well, I'm going to write the formula in big blue from above. I'm just going to shrink my work a tad. So I'm going to write the formula from above, tk plus 1 equals nck, a to the n minus k, b to the k. And then I can expand that. So what we have is, I'm looking for the 5th term, so t5. And from above, I'm going to remember k is always 1 less than the term number. So if I know k plus 1 is equal to 5, I know k is 4. I'm going to get there in a second. The rest of the formula, n from above, n is simply 6. N is the exponent from the general formula. So 6ck, we've just established. Off to the left, if k plus 1 is equal to 5, k is 4. K is always 1 less than the term number. A is a from our example. N, 6, minus k, 4. B to the k, 4. And I can clean that up. 6c4 is 15. A, 6 minus 4 is 2. B to the 4. And without expanding it like I have in the table, I have simply found a term in the future. Now, the next section is a lot more difficult, so you'll feel free to read through the notes and find out which term has that term in it, which term is constant, etc. Really difficult algebra. I'd be surprised if they ask you those questions. I didn't see them until university. Thank you very much for your time. I've enjoyed this a lot. I'm going to be updating notes and homework for the remainder of the century, So keep posted. Please feel free to let me know if there's any problems. I know there's been errors every once in a while. I'd really like you to let me know, and I can fix those as quickly as possible and correct that for hopefully you or later years after that. Again, my name is Nicholas Craig. This is NAC Academics. If you need any help, if you can't get to our office, please feel free to send us a text message or book on our website. Maybe we can get something going online. I really hope you like it. Thank you very much for your time. Please spread the word.